Welcome to lesson 19, problem number 3, where we are going to go over how to factor perfect square trinomials. Now, perfect square trinomial always has the first term is something that's a perfect square, the third term is something that's a perfect square, and the middle term is the square root of the first, which in this case would be a, times the square root of the second, which in this case would be b, doubled. So what we get is this term being twice the square root of a, or the square root of a squared times the square root of b squared. So that's 2ab. If it's a minus, if it's a squared minus 2ab, everything's the same except for it would be a minus b and a minus b when we factor it. So let me kind of show you an example of this, and you can always email me with questions and multiply it out yourself to see that it really works. So let's look at 3a. Besides the fact that we're told that these are perfect square trinomials, we can test to see that the first term is a perfect square, the last term is a perfect square, and the middle term is twice the square root of the first times the square root of the second. So the square root of k squared is k, the square root of 25 is 5, 5k doubled is 10k. Yep, we have a perfect square trinomial. Now, the easiest way to factor this then is to just say it is simply k minus 5, the quantity squared. Now, you might have been thinking, well, wait, can't we just do that as an AM problem? Yes, you can. So if you'd prefer to just think of it as what adds to negative 10 and multiplies to positive 25, and you could say, oh, it's negative 5 and negative 5, you know it's k minus 5 times k minus 5. So you're probably sitting there thinking, well, why would she ever make me know that I have to recognize a perfect square trinomial? You'll see that in C and D, which are light bulb problems. So if you don't want to do the light bulbs, you can do it just as an AM problem. So B would simply be x plus 7 times x plus 7, or x plus 7, the quantity squared, because the two numbers that add to 14 and multiply to 49 are 7, but you can also look at it based on what we know here. Now, I showed you all that at the beginning because I want you to recognize how to do the light bulb problems if you so choose. So this is a perfect square trinomial because we have 8y, 7x. 7x times 8y is 56xy, doubled is 112xy. So all we have to do to factor this is say 8y plus 7x, the quantity squared. Same thing with this one, except for this time, there actually is a greatest common factor that we can take out first. The previous problems, there was not a GCF, but here we can first take out a 16 because that goes into every term. So then we have 16a squared b squared minus 2 abcd plus c squared d squared. It's a perfect square trinomial because we know the square root of the first term, we know the square root of the last term. Those two multiply together and doubled gives us the middle term. So our final answer is simply 16 times AB minus CD, the quantity squared. Okay, those were tough, those light bulb ones especially, but A and B you could do in two different ways. Just want you to be familiar with what a perfect square trinomial is. Great job. See you next time.